Okay, this video is about integer exponents in algebra. So, this expression is read as a to the nth power. Also, you can read it as a to the power of n. And the definition of a to the power of n depends on whether n is positive, 0, or negative. If n is a positive number, if it's a positive integer, then this is how you define a to the power of n. Notice that today we are looking at integer exponents. So n is an integer. 0, plus minus 1, plus minus 2, plus minus 3, and so on. If n is a positive integer, then a to the power of n is defined to be a times a times a times, and so on, n times. So, for example, 2 to the power of 4 is defined to be 2 times 2 times 2 times 2, which is 16. Or negative 5 to the power of 2 is defined to be negative 5 times negative 5, which is 25. Notice here that when I'm raising negative 5 to the power of 2, I am using these round braces, which is necessary because there is a difference between negative 5 to the power of 2 and negative 5 to the power of 2. The difference is that since raising to power has precedence, it has priority over multiplication, if you do minus 5 to the power of 2 and there is no brace, first this 5 is raised to the power of 2 and then the result is multiplied by negative. So this is negative 5 times 5, which is negative 25. So as you can see, first 5 is raised to the power of 2 and then the result 25 is multiplied by negative, gives you negative 25. But this one, as you can see here, it's negative 5 multiplied by itself, which is 25. So this expression evaluates to negative 25, this evaluates to 25. So whenever you are raising a negative number to a power, don't forget the round braces because that makes a difference. Another example, 0 to the power of 3. That is 0 times 0 times 0, which is just 0. So you can raise a positive number to a positive power, you can raise a negative number to a positive power, and you can raise 0 to a positive power. Now, if n is 0, then you have a to the power of 0. We define that to be 1. And in this case, a cannot be 0. So, for example, 2 to the power of 0 is 1. Or negative 4 to the power of 0 is 1. However, 0 to the power of 0 is undefined. So the third case is where n is something negative, n is a negative integer, something like negative 1, negative 2, negative 3. So if n is a negative integer, then this is how we define a to the power of n. It's 1 over a to the power of negative n, and if n is negative, then negative n will be positive. And this denominator here follows this formula that we defined here. So let me give you a few examples. 2 to the power of negative 4. This is 1 over 2 to the power of 4. So 1 over the same base here and the exponent has been negated. And as we calculated here, 2 to the power of 4 is 16, so this is 1 over 16. Another example. Negative 5, so negative 5 is our base raised to the power of negative 2. This is 1 over the same base, negative 5, raised to the power of 2. And as we calculated before, negative 5 to the power of 2 is 25. So it's 1 over 25. What about 0 to the power of negative 3? If you want to follow the same formula here, this is 1 over 0 to the power of 3, which is 1 over 0 times 0 times 0, which is 1 over 0. And as you can see, this is also not defined. So, as you can see, you can raise 0 to a positive power, and that is 0. But you cannot raise 0 to the power of 0, and you cannot raise 0 to a negative power. So 0 to the power of 0 is undefined. 0 to a negative power is also undefined. Oh. Okay, now let's take a look at some properties of exponential expressions. The first property is when you have a to the power of n times a to the power of m. So you have the same base a, you have different powers. In this case, you're going to use the same base and you're adding up the powers. For example, 2 to the power of 3 times 2 to the power of 4 is 2 to the power of 3 plus 4, which is 2 to the power of 7. Or negative 3 to the power of 2 times negative 3 to the power of 4 is negative 3 to the power of, if you add up 2 and 4, gives you 6. So don't forget that you need to have the same base, and the two expressions need to be multiplied. The second one is a to the power of n over a to the power of m. Here you have the same base, you have different powers, and the two expressions have been divided. So it's a to the power of n minus m. For example, 5 to the power of 4 over 5. Okay, this 5 here does not have a power, but a power of 1 is always implied. So this is 5 to the power of 4 minus 1, which is 5 to the power of 3. Next property, a to the power of n, the whole expression raised to the power of m. In this case, you're going to multiply the two exponents. So it's a to the power of n times m. For example, 2 to the power of 4, the whole thing raised to the power of 3 is 2 to the power of 4 times 3, which is 2 to the power of 12. Next expression, ab to the power of n. This is a to the power of n times b to the power of n. So, for example, negative 2 times a to the power of 3 is negative 2 to the power of 3 times a to the power of 3, which is, okay, negative 2 to the power of 3 is negative 2 times negative 2, which is negative 8, a to the power of 3. Next. a over b to power of n. This is a to power of n over b to power of n. Let's look at one example. 2 over x raised to power of 3. This is 2 to power of 3 over x to power of 3, so it's 8 over x to power of 3. Okay, there are two more properties left, and these two other properties are going to help us get to the negative exponents. So imagine a and b are positive integers, and you have a to power of negative m over b to power of negative n. So if m and n are positive integers, then negative m and negative n would be negative integers. So if you have such a case, you want to get rid of negative numbers, the only thing you need to do, you need to bring this base to the denominator and flip the sign. So negative m becomes m, and you move this base in the denominator to the numerator, and you negate the power. So it's like this. So for example, negative 2 to power of negative 1 over x to power of negative 2 is negative 2. So I'm using the same base, move it to the denominator, to power of 1 over x, same base, move to the numerator, to power of 2, which is x squared over negative 2 to power of 1 is just negative 2. A power of 1 is always implied, I don't need to write that, which is the same as negative x squared over 2. Okay, and the last one is a over b to power of negative n. This is b over a to power of n. So if n is something positive, then negative n would be negative. And if you have a negative power like this, you have a fraction raised to a negative power, you just invert the fraction. So instead of a over b, you have b over a, and now you can use n, which is a positive power. So for example, 2 over 3 raised to power of negative 1 is 3 over 2 raised to power of 1, which is 3 over 2. Okay, now let's look at some more examples. So in this kind of exercises, you're usually asked to simplify the expression and write only, so that your final answer should only have positive exponents. So after you simplify, if you have any negative exponents, you have to get rid of it. 2 to a to power of 2 times a to power of 3 over a to power of 2, the whole thing to power of 3. That's our first example. Here we have the same base a, different powers. The two expressions have been multiplied. You can add up 2 and 3, gives you 2 plus 3. And here you have a to power of 2 raised to power of 3, so you have to multiply the two exponents. It's a to power of 2 times 3. So it's a to power of 5 over a to power of 6. Okay, don't forget that a to power of 5 is just a times a times a times a times a. And a to power of 6 is a times a times a times a times a times a. Now you can see this cancels this, 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 so you're only left with 1 over a. You could also, so from here you could also do this. You could say this is, I have the same base, different powers, they have been divided, so this is a to power of n minus m. So 5 minus 6, that's a to power of negative 1, but this is a negative exponent. I use the definition, so this is 1 over a to power of 1 or 1 over a, same answer. Okay, let's look at another example. Uh, 3x squared to power of -2 over 2y to power of 3 raised to power of -3. Okay, as you can see, I have a negative exponent here, I have a negative exponent here. The first thing I can do is to get rid of these negative exponents. So let's move this base, 3x squared, to the denominator and negate the power. So -2 becomes 2. And I move this base here to the numerator and I negate this power. Okay, next step. I have to raise 2 to the power of 3 and also y to the power of 3 to the power of 3. So this is 2 to the power of 3 and then y to the power of 3 to the power of 3. And in the denominator I have 3 to the power of 2 times x squared to the power of 2. 2 to the power of 3 is 8. Y to the power of 3 raised to the power of 3, I have to multiply the two powers. Gives me y to the power of 9. And here 3 to the power of 2 is 9. X to the power of 2 raised to the power of 2, I have to multiply the two powers. Gives me x to the power of 4. Okay, another example. 2y cubed over x to the power of -2, this raised to the power of 4. So this is 2y to the power of 3 to the power of 4 over x to the power of -2 to the power of 4. So 2 to the power of 4, y to the power of 3 to the power of 4, and x to the power of -2 to the power of 4. 2 to the power of 4 is 16. Y to the power of 3 to the power of 4, I have to multiply the two exponents. That gives me y to the power of 12. And x to the power of -2, the whole thing raised to the power of 4, that's x to the power of -8, because -2 times 4 is -8. So I'm left with a negative exponent here. So in order to get rid of this negative exponent here, I need to move that from the denominator to the numerator and negate the power. So this equals 16 y to the power of 12. So this one stays on top, and this x is moved here, becomes x to the power of 8. So when I'm moving this to the numerator, I'm replacing it with 1. So here I have over 1, but over 1 is implied, so I don't need to write it. So that's the most simplified form. Okay, one last example. 2xy to the power of -3 times y x to the power of -1 to the power of 0 over -x to the power of 2 y, this whole expression to the power of -2. Okay, so first of all, this expression here has been raised to the power of 0, and we know that a power of 0 means this evaluates to 1. So this evaluates to 1. I have negative exponents here, so I move them. 2xy goes to the denominator, raised to the power of 3. Negative x to the power of 2 times y. So this expression here, this base here, with no change, I move it to the numerator, and the power gets negated, becomes 2. Okay, then I have negative x to the power of 2 raised to the power of 2. This is just a negative x to the power of 2 times 2, 4. And y to the power of 2, 2 to the power of 3, 8, x to the power of 3, and y to the power of 3. Negative 4, negative x to the power of 4 is just like negative 1 to the power of 4 times x to the power of 4. So this is just negative 1 to the power of 4 x to the power of 4. Y to the power of 2, 8, x to the power of 3, y to the power of 3. So negative 1 to the power of 4. Instead of negative x to the power of 4, I have negative 1 to the power of 4 x to the power of 4. As you can see, negative 1 to the power of 4 is just 1, because negative 1 times negative 1 times negative 1 times negative 1 is 1. So this is just 1. So I'm left with x to the power of 4, y to the power of 2, 8, x to the power of 3, and y to the power of 3. Now let's simplify this. So I have x, 4 x's, times y over 8, and then x, y. So this x cancels this one, this cancels this cancels this. I'm left with one x in the numerator. This y cancels this y cancels this y. I'm left with one y in the denominator. So I have x in the numerator, 8, and y in the denominator, and that's the final answer, x over 8y. Another thing I could do was I could do this. I could say from here, I could say this is x to the power of 4 minus 3, so 1, and y to the power of 2 minus 3, so negative 1, and this 8 is just 1 over 8. Which evaluates the same thing. This is just x in the numerator over 8y. So you can do it the way that looks easier for you. And that's it.